Something funny happening. All right, go to number 7 in the packet. Go to number 7. Everyone needs a flashcard that looks like that. I call it the limit flashcard. We'll use it all year long. If we did more complicated limit problems, this may not be perfect, but I've yet to see a limit problem on the AP test where this wasn't immensely helpful. So every time we encounter a limit problem, I'll always say, hey, what does the limit flashcard tell us to do? So put that on a flashcard or somewhere else where you will make sure it is memorized. Spin the magic ball. Okay, if you look at the very front of the pink packet, it says that for every single problem you're supposed to do two things. You are supposed to find the limit as specified, but you're also supposed to determine if the function has a horizontal asymptote. So every problem has two parts. If you look at the answers, you'll see that they are broken into two parts. For example, here on problem 6, this is the part of the answer that's, problem 4. This is the part of the answer that's referring to finding the limit as specified. And then this is the part that's talking about the horizontal asymptote. So two separate things to do for each problem. So back to 7. We look at the limit flashcard. It says, we are not finding a limit as x approaches infinity. So we skip that. We go to the green, which says we should factor and divide. Okay, here's a golden hint, don't forget it. When we're finding a limit, and actually most of the time in AP Calculus, if we factor, we're doing it so we can divide. Like if we can't divide, there was no reason to factor. So that really helps get us on the right track as far as factoring. For example, if I can't find a factor of x plus 2 in the numerator, factoring is useless. So I'm assuming, being a nice canned problem, that I'm likely to find a factor of x plus 2 in the numerator. Before I do any sort of complicated factoring, I want to do easy factoring first. So I want to just take out a 2. So, again, your notation must be correct, otherwise they won't give you points. So you must have an equal sign. If you don't put equal, the grader can't follow your work, and they won't try. They'll just look at the work and say, this is like an essay with no capitals and no periods. And they just throw it in the garbage. Okay? Serious. Like they're not going to try to read your work if it's not readable. So, I write equal. You must write limit, because we have not resolved the limit question. We're just working on it. Now we're going to factor a 2 from the numerator. Questions about anything? I'm bothered by that. Sweet. Again, the goal was to find a factor in the numerator that matches a factor in the denominator. So we're looking for an x plus 2 in the numerator. So we do equal again. You still have to write limit. I'm hoping there's an x plus 2. The way that it's best to factor in this class is to start here. What multiplies to make 2? 2 and 1. So now that works. Questions? Please.
Will you always take the denominator and put it in the first parentheses? Is that like
Oh, 2 points. Not necessarily. That was just kind of happened. Okay, cool. Next thing. The reason we factor is because once we have strictly factors, we can write them out separately. You can't do this with terms. Here's a little reminder of terms versus factors. There's a sign on the wall from Amanda Lindstrom to help as well. But if we have factors, we can write things out separate. So we're going to do this.
So then on the flip side of a cross section, is this thing called a solid of resolution. Solid of resolution now is going the opposite way. You're going to take a two-dimensional object and you're going to rotate it and make it like a three-dimensional object. That's what is a solid of resolution.
Okay, does anyone have trouble seeing that the green and the blue are identical? If you can't see it, talk to me, Kira.
Can you kind of explain how you shifted everything to get from the blue to the green?
So let's think of it this way. When you multiply fractions, we take top times top times top. Good? So really, this is just 2 multiplied by x plus 2 multiplied by x plus 1, which is what I have here.
Oh, okay.
Does that help?
And then 1.
It's a really good question. Take 3, Kira. Take 3, please.
You're just doing that to cancel out the x plus 2?
Right on track. Take 3 as well. However, you have a rule in my classroom. We avoid using foul language. So the reason I don't like the word cancel is it leads to mistakes. Here's why. So Braun is correct. That's why I gave him 3. But yeah, no more cursing and swearing. We'll get out a swearing jar and you can all pay me.
Not the last time.
It's all good. Yeah, this word is forbidden. This word is also forbidden. This is credit to Reese Curtis. This is credit to Lindsay Worthen, if anyone knows them. Here's why we don't want to say cancel, to be honest. This right here, that can only have one of 2 values. It can either be undefined or it's equal to 1. It cannot be anything else. So raise your hand if you know when this is undefined. Here we go. Like this is x plus 2 divided by x plus 2, which means you could plug in any x. What x will cause that to be undefined? Hands up. What x will cause the yellow to be undefined? That's better. Let's go, Sophie.
-2.
If I plug in an x value of -2, what will the top become, Sophie?
0.
And the bottom?
0.
0 divided by 0 is undefined. So if you plug in an x of -2, the yellow is undefined. How many knew? 0.2 for Sophie. What's the other value that the yellow will always equal? So if x is -2, the yellow is undefined. What other value can the yellow have? Hands up. This is why we don't want to say cancel. You got to keep track of what's really going on. Corbin. If x is any other value other than -2, then the yellow is 1. 2 for Corbin, 1 if your hand was raised. We want to talk about that. Please.
I'm just confused on why the x plus 2 is not under the 2 and like, if it's the denominator for all of them,
Oh,
why is there 1?
I'm separating out the factors to make it easier for us to talk about. So, for example, are you comfortable that when you take one fraction times another, you just go top times top times top? You good there? So can you see that this times this times this is this? And then on the bottom, it's just 1 times x plus 2 times 1. Better? 2 more. Keep asking. Don't stop. Pretty good? Sweet. So the yellow can be one of two things, undefined or 1. Raise your hand, please. For this problem, which is it? While finding this limit, must we think of the yellow as being undefined, or must we think of the yellow as being 1? And why? Key is to remember the why, because then you can remember it for the future. Let's go, Sarah. Certain.
I took undefined.
Tell me what?
Because the limit is x on its way.
Super close. Stay with me. Look, everybody gets 1 who had their hand raised. Sarah's going to get more. Just talk to me for a second. All of your logic was perfect except for one little tiny thing. We're trying to figure out what this formula here becomes when x is almost -2. If x is exactly -2, it's undefined. That makes sense? But for the limit, we're not looking for what's happening when x is -2. We're trying to figure out what happens when x is almost -2. So if x is anything other than -2, the yellow will be 1. I don't know if that helped. Better? 3 points, please.
I thought that if it was almost -2, the negative would be on the other side. Or there would be like a negative on the other side.
Like this,
Yeah.
or like this. 2 points for Lissy. You're just misremembering, no big deal. When we write this, we learned last time that that really means we must go determine both the left and the right limit.
Okay. So
So,
it just kind of did the step for us.
correct.
Okay, I see.
Or to be more fair, we're just doing this in our head
Okay.
without writing it down just to save some writing. Is that better?
Yeah.
2 more. Anyone else? Okay, look, don't get, you have to make sense of this. It's key to the rest of the year. This is saying x will never be -2, only close. Therefore, the yellow will equal 1. Questions?
Wait, when it says x goes to -2, that means it's
Say it again.
That means it's the plus and the minus, right?
Correct. Well said, Brady. Well said. I'm not writing it out just to save some writing to prevent from getting too overwhelmed with notation, but we are thinking of that.
Okay.
So I'm thinking of x being a little less than -2 and a little more. So Brady's going to help me here. So when x is almost -2, what's this, Brady?
That's still 2.
That's 2 because that's nothing to do with x. When x is almost -2, what's this?
1.
1 exactly and precisely. So 2 times 1 is 2. When x is almost -2, Brady, what's this one?
It'd be like -1.19999 plus 1.
Yeah. For our class, good enough to just say, it isn't -1, but it's dang close.
Okay.
So this is almost -1. So now you have 2 multiplied by 1 multiplied by almost -1. What's the result?
-2.
Almost.
Almost.
So the limit is precisely -2. 3 points for Brady.
How come if it's x is getting closer to -2, how come you wouldn't plug in like 1 point or -1.9999 for all the x values? Wouldn't that make, because it wouldn't be 0 exactly, it'd be like, for the yellow box, it wouldn't be.
No, that's perfect. Here's what Boston just did in his head. We really are plugging into that number, -1.9999999999. But whatever the top becomes, the bottom becomes the same thing. And it isn't 0. So something divided by itself is 1. Hold on, 2 more.
You wrote like equals -2, will we have to write limit x is almost -2 equals? Like, will we have to write the beginning of the problem out when we write the answer?
2 points for that. Here's how the grader's going to read it. You're being asked to do this. You're telling the grader that this is a different limit problem with the same result, hence equal. Here's another limit problem with the same result, so it's equal. Here's another limit problem with the same result, that's also equal. But right here, we were able to figure out the value of the limit, so we're done. We're not finding another limit, this is the value of the limit. Does that help?
Yeah.
It's the same as doing this, Jenna, putting equal -2 here. Which would also be legal, that'd be fine as well. Did that help?
Yeah.
2 more, please.
In this case, we're talking about limits. Will it ever be undefined then?
For limits, the only way to get a limit that is non-existent is to have the left and right be different, or have the limit go to infinity and then we call it a non-existent limit. So we talked about that in the last homework. I don't think that happens on the pink, but it could.
Okay.
Does that help? 2 more. Anybody else? Corbin.
I'm just kind of confused because like last time we were finding like the left-hand limit first and then the right-hand limit, and this one we just like find just the overall limit is 1.
I'm going to give you a ticket for this one. You said something really, really crucial. Every single time we find the overall limit, which is what we're doing here, you really have to find both the left and the right. All we did was we did it mentally without writing it down. So when I got to here, you need to be thinking, what is this going to equal? What's that going to equal when x is a little more than -2 or a little less? And our conclusion was, this part's easy because that's something divided by itself. So for either case, this or this, the yellow box is going to be 1. And then this orange box for either case is going to be very, very close to -1. So I've checked both sides and I'm finding the same result. Did that help? 2 more. Actually, bring you a ticket. Sorry, I forgot. Go ahead.
On the homework, do you want us to write like the third way that you wrote it, or just can we go the second way and just put equals -2?
Gotcha. If you can see how to finish from here, you don't have to write this.
Okay.
I write it out for clarity because you could tell from the discussion that it wasn't perfectly clear. So, yeah,
Wait,
please.
so how do you have to do both the minus and the positive, right?
Yep.
So you have to rewrite it out again.
Oh, awesome. Here's the difference, Brady. On the homework last night, they said to analyze the continuity. So on an AP question, when they want you to talk about continuity, they're going to want to see those separate limit statements.
So like, how would you write that out?
You'd have to literally say, like we did last time, the limit as x approaches, whatever, as x approaches 2 from the left and from the right. It's not required here because they just said go find the limit. So we were allowed to do more in our head without writing it down.
So when it says go find a limit, you can just find one of them.
When we go find the limit, we are finding both.
Yeah.
We just don't have to write it down. And we discover that it doesn't matter which one we're looking for, the result is still the same. So we found them both. We have to do that. We just didn't have to write it. Did that help? 2 more.
So is this like finding overall limit?
This is finding an overall limit. It's perfect, Paige. This is finding an overall limit. And we are finding it by doing the left and right limits,
So
just mentally. Keep
So
going.
is the individual values, like the 2 over 1, x plus 2, and x plus 1, is those the left and right limit? Or is that like separate? Are we just like factoring? Because like my mind is thinking like of putting 2 numbers together to get the overall limit.
Oh no, that's my bad. 2 points. What we're doing is, okay, everybody look up. Look up. This is dead on. If you sit in class and you just learn how to do the homework, be prepared to fail the test, I guarantee it. Like, you have to make sense of what's going on. Like, what are we really doing here? Here's the big idea. We have a formula here in blue, the top. that formula is for calculating y values. And the limit problem is all about figuring out if the x value is one of these, what's the y value? So we are trying to find two different y values that go with two different x values. Is everybody clear on that? That's what we're doing. How we accomplish that is we factor to make it easier to see what's happening. I'd like a vote here. Look at the blue formula here. Look at this, I'll put it in orange. Orange formula here. I need you to vote. This means true. This means false. The blue formula is exactly the same as the orange formula. They are perfectly equivalent. True, false. If you're doing this, give yourself this. They are perfectly equivalent. Back to Paige's question. Back to Paige's question. We're just using the orange formula to go find two y coordinates. But we just didn't write anything down. We just thought about it. And we said, oh, okay, if I plug in an x that's either this one or this one, this will be 1. 2 times 1 is 2. This will be close to -1. Oh, so 2 times -1 is close to -2. So for both this x and this x, the y value is close to -2. Therefore, just like we did on last night's homework, we compared the left and right limits and decided that they were the same, so the overall limit is -2. Did that help at all?
Yeah, so
Sure.
is it like how when you see have like the piecewise function and you can like use like if it's 2.999 you technically use 3, and if it's 3.001 you technically also use 3.
That's
So,
correct.
So are we you're technically putting it in, like it would be the same number, I guess.
What's happening is here's our x's, and we're finding y values, and we're finding two different y values. They're not identical.
Yeah.
But the limits would be identical,
Yeah.
just like last night. Better?
Yeah.
Well done. Please, Brady.
So as x approaches -2 to the left, would that be negative like 1.99999 or like -2.1?
So if I plug in -2.001, this is going to be like -1.0001. Multiplied by 2, it's going to be like -2.000001.
Well, it's like when it says like, so like the left limit, would that be like a little less than
It's going to be a little less than -2.
So that'd be like -2.1.
-2 minus.
Minus.
So it'll be -2.00001.
Yeah.
And then the right-hand limit's going to be -1.9999999.
Okay.
Well, not the limits, that's what the y coordinates are. Like Paige said, the limits are -2.
Okay.
2 more.
On like the list of steps, like if you don't do like the first one, maybe the second one, then you do the last one too. Like it's like
So the first two, how do I say this? If the limit is not approaching infinity, Braun, we just don't do the blue at all. If the limit is approaching infinity, we might have to factor and divide, but I haven't seen it be very common. Well, no, back up. We'll do a little factoring and dividing as well. We always do the last one.
So if you were to graph these points, it would
Except
like,
if x is going to infinity, then there is no left, right, but anyways. Keep going, sorry.
if like then you'd have your x value, and then that is just saying that they're going to be at the same height, like that's, but to the left or the right a little bit differently. Is that like, I'm just trying to picture it in my head.
You're doing really well. So that's the worst graph ever. Try again. So what, hold on, what Piper is doing is exactly the right idea as far as she's making sense of the big idea. The big idea is x's and y's. Here's x equal -2. We have not, well actually we did figure out when x is -2, we don't know what the y value is. But we now know that the y value when x is almost -2, they're both really close to -2. And so they're like here and here. And then in the middle we don't know. Does that help? 2 more. Please.
So to get the like actual answer for the problem, are we gonna have to write like the therefore this is a jump or whatever it is?
Oh, gotcha. This particular packet is not asking you to analyze the continuity. It simply says find the value of the limit, which we have found. So we're done with that part. Two more.
And sorry, the reason
You're
that
good.
there's an open circle on the -2 is because if you would input -2 into the x, it would be undefined.
Correct. Because of that box right there. Two more. Outstanding. This is what you do to succeed in this class. You just keep drilling and say, okay, do I understand what it comes, what does it mean, where did it come from, what was the reason? Then you put it all together and you'll do great on the test. Questions? Please.
And with some questions, will there be like two limits, kind of? Like a right hand and a left hand? Or like the overall one? Do you
So
know what I'm asking?
every time we do a limit, we always must consider both the left and the right. On the last homework, we did it explicitly by writing it down. This one, we're just doing it mentally. But we are considering both the left and the right. And the overall limit is always found by comparing the left and the right. Did that answer your question?
Yeah.
Two more.
Will there be any questions where like the left limit's different from like the right limit?
Like the ones you saw last night, it was very common
Yeah.
for the left and right to be different. When you have a problem like this where there's just one formula, it's very uncommon. About 99 out of 100 times on the AP test, if they give a limit like this, the left and right will match.
Because a formula like that would make it so the line goes like straight. Or
It
like,
does.
it would
It's
go-
probably a curve.
Yeah, like it would, not straight, but like it would curve through, instead of having like it start there, end at the 2, and then jump up to like.
For our class, two more for Paige. For our class, jumps 99% of the time only occur in piecewise functions. Single formula, we don't see a jump. The only exception I've ever seen is that that formula contains an absolute value. It gets significantly different, more
What
difficult.
about the R?
Removable occurs very commonly in this type of formula. In fact, that's what this is. Because we just figured out that the left and right limits are the same.
Oh, right, okay.
No, you're good. But the value of the function is undefined. So this formula has a removable discontinuity. Sam?
How would the overall limit be non-existent?
So the overall limit can only be non-existent if the left and right don't match.
And how would that happen?
It won't happen in a formula type problem like we're looking here. At least I've never seen it happen unless the formula contains an absolute value. We'll wait to see that a little bit later.
For these
Two more.
questions, will you end here or will you do like the therefore f of x is like that kind of like, will you have to like write that out or can you just end it with that?
This one doesn't require any, like before, the reason there was a therefore is because they asked us to talk about the continuity. So we had to have some sort of conclusion about that. This just says find the limit. So we're good. Corbin.
Just for like writing on the AP test, when you get your final answer, do you want to put a box around it?
You don't have to. If you have the right equal signs, the grader can follow it just fine. I box all the time because as I'm talking, part of it's because the video's running, and if I don't keep circling things, when you're watching the video, you can't tell what I'm pointing at. So that's why the board has so many circles. So yeah. Sorry about that. I need a button on my pen that says, just show the tip of the pen without drawing a actual circle, but I don't have such a feature. So I guess I could choose white and then it would work. No idea. Questions? Awesome. Hey, we gotta do the second part. The second part says you gotta find if there's a horizontal asymptote or not. Okay? So make this into a, can I erase this part?
Yes.
Like, please, Ryan, like, get rid of it. Okay. Go. There we go. You need a flashcard that says this, please. Make it. Right there. Please, Ryan.
Why can't you say it?
Oh, that's actually the AP test. If you use the word it as you're explaining something, it's really common to make what's called a misreferenced pronoun. It's an English error, and they won't give you any pointers. So I had Reese make a nice sign for me to just say, just don't use it. So, an example would be, if I'm talking about f of x, it's much better to just say f of x. You say it, they're like, what are you referring to? So, come on. Please.
Do we need to have two separate flashcards, or can we just put them on the side?
Up to you. Like, the flashcards are just to help you have a good memory aid. Use whatever system works best for you. There are two separate ideas that I've got to have memorized, that this is what I do when I'm finding a limit. This is what I do right here if I'm finding a horizontal asymptote. And of course, this leads to this because it says go find the limit. So, all right, here we go. So we need to find the limit as x is approaching infinity this time. It is not wise to start over from the beginning because we've already done a lot of work. Let's take advantage of that work. All of you told me that we had this other formula that was equivalent to what we started with. And you also told me that x plus 2 over x plus 2 is going to equal 1 as long as x isn't a negative 2. Well, when x is approaching infinity, x isn't a negative 2. So we have a new limit problem. Okay, notice I did not put equal because the new limit problem isn't equal to the first one. It's different. So don't put equal, the grader will have a fit. We're now approaching infinity, but we only need to do it for this formula because of our previous work. Like that. Questions? We have a huge head start. Let's take advantage of the head start. Everybody good to there?
Why isn't the x plus 1?
The x plus 1 over 1? Oh, we didn't write down the third part because what we had before.
Oh, sorry, the middle part. Sorry, I get it.
You good now? You're okay. Keep asking. 2 more points. Please. Paige.
Sorry, I'm confused by the middle part.
So the middle part was it looked like this. 2 for Paige. We had x plus 2 divided by x plus 2. Is that correct?
Yep.
So we're worried about what's happening when x gets big. When x gets big, we'll have some large number divided by the same large number. So it'll simply equal 1. It won't matter how big x gets. That will always equal 1. 2 times 1 is just 2.
So you, okay.
So it just
Can you
doesn't
write down
matter.
if you want?
What's that?
Can you write it down?
Oh yeah, for sure. Did that help?
Yeah.
2 more. Hey, everybody look at me. Look. I really try super hard to get you talking and just any little thing that pops you like, where did that come from? Where did it go? Just keep talking. Don't ever hesitate. You good?
Yeah.
Okay. So I'm gonna go with this one. So raise your hand then. If x grows forever, this is our formula for finding the y-coordinate. What y-coordinate are we going to get? Hands up. Limits are just x and y. So the x is going to just keep getting bigger and bigger and bigger. What's going to happen to the y? Hands up. Here's the formula for finding the y value. If x just gets bigger and bigger, what happens to the y value? Alexis.
It's smaller.
So let me talk you through it. You're just backwards. Is that okay? No worries. Think of x as being 100. So what will this be, Alexis? 101. Times 2 is bigger. 202. Okay? Now we put in 1,000. So x gets bigger. This will become 1,001. And then we multiply by 2, it gets like 2,002. So the bigger x gets, the bigger y gets. How many knew? 0.2 for Alexis. So this limit is infinity. Okay, back to Lily's question. Now we do want to have some sort of conclusion, like we've learned something. We need to tell them what we've learned. We learned that as x approaches infinity, y also approaches infinity. If we were to do the same experiment for negative infinity, we would find that we're plugging in very large negative numbers, so y would be approaching negative infinity. Question? Please, please.
So that means that there is an asymptote? Or?
An asymptote is when we have this sort of pattern, but the y value is approaching something finite.
Oh, okay.
So it's horizontally, to use a non-existing word. Like this graph is going to go, like if I try this, it's just going to keep going. And if I'm doing, so like as x goes negative, the graph's going to go down.
So if there was an asymptote, what would like be the graph?
It would be like as x approaches infinity, y approaches 5.
Oh.
2 more, please.
Where did like the -2 go? I'm just confused, like, as y approaches negative infinity, it's gonna hit a -2 and it's not gonna exist, so like how can it, do you know what I'm saying?
Oh, got your question for sure. Have I paid you an extra ticket today? No. This is really good. You, yes, Piper, yeah, I said it wrong, sorry. As x approaches, that's really good. Everybody look up, look up, look up. It's really good. You thought through it perfectly. You said if x is approaching negative infinity, as I sequence through the x values, I'm going to hit -2. And so I would have a problem. Like I'm going to hit, you know. That's not quite what this means. That means if x is allowed to, it's hard to explain, that's a really good question though. Like it's like if x becomes more and more negative, what happens to y? Like we've long passed x equal -2, we don't even care. We just care like when x is -12 quadrillion.
Okay.
Does that help a little?
So
It's not the whole
stopping
path.
anywhere, so
No, it's not the whole path. It's just like, imagine what happens if x is really negative. So we don't worry about when x was just -2.
Okay.
That help a little? That's a really good thought. Please.
I'm just confused, how do you know there's not a wonderful asymptote?
Just by definition. So the definition is simple. If as x approaches infinity, you discover, so back to Piper's comment, if you discover that as x is very, very large, the y value is getting close to something finite, 3, then you have a horizontal asymptote. If the y value is just growing forever or shrinking forever, that's not a horizontal asymptote.
Okay, so if the y is like approaching like a literally small number, it's gonna be
Any
infinity,
number.
if it's just infinity.
Any number other than infinity,
Okay.
horizontal asymptote. Better? 2 more, please.
And it's not saying that the x and y are equaling as they go on. It's just
No.
saying, because the y would be 2 times bigger. so-
That is correct. Yep. 2 more, please.
Do we have to find if it's approaching a horizontal asymptote on every question?
For this pink packet, yes. I'm just trying to give you some experience with what you're going to hit in the future in a very different format, but just the idea that I want to make it, I really want it to sink in that this is what we're doing when we're talking about horizontal asymptote.
Will they ask for it if they want you to find it?
They'll do it in a more creative way, I'll be honest. I'm just trying to prep you for these more creative questions. 2 more. Solid. We are now completed item 7. So, sweet.